here we go. Back again. All right. All right, problem number 9. We're almost there. Consider the following rational functions. Choose the graph of each function from the choices below. Let's go back to blue. First thing is always to factor everything. Sometimes that is redundant and unnecessary, but x minus 4, x minus 1. Sometimes it's redundant, but you want to make sure to you want to do it because the factor form is where you see the properties of the graphs that you want. Okay, and then for the bottom one, 3 times x minus 1 over x minus 4 x plus 1. All right. So when we're looking at these graphs, we're looking at our function here. We see that we have two vertical asymptotes at x is equal to 4 and x is equal to 1. So no, yes, that's a possible. 4 and 1, that's a possible. No, that's a possible. Okay. So the easiest thing to do from this point is there is no x-intercept. It does not touch the x-axis because this top cannot equal 0. So if I do that, you see that for this one, it has an x-intercept, and for that one, it has an x-intercept. So just by a little bit of process of elimination, we know that this is graph C. All right. All right. So for the next one, vertical asymptotes at 4 and negative 1. Let's do a different color then. Let's do purple. Let's do purple. All right, at positive 4 and negative 1. So positive 4, negative 1. That's a possibility. Positive 4, negative 1. That's a possibility. We know it's not this one. Positive 4, negative 1. That's a possibility. Let's do a circle. There, there, and there. Okay, we know we have an x-intercept at positive 1. Okay, so positive 1, yes. Positive 1, yes. Positive 1, no. Positive 1, no. So if that's the case, this is the only, graph A is the only one that it could be. Only one it can be now. Just A. Just A. All right, so that's the matching. And you see we didn't have to go very far in examining our properties. We did horizontal asymptote. Well, we did vertical asymptotes. We didn't do horizontal asymptotes because they were all at 0. Yeah, they were all at 0. So, but then we did x-intercepts, and then that got us what we needed to be. All right. Question number 10. Now we're changing gears. Graph this function and give its domain and range using interval notation. So let's change the red and let's make this narrow. The red will be the original function. So the original function of f of x is equal to the x at 0, 1 is there. 1, 2 is there. 2, 4 is there. Negative 1, 1/2. And this is the original function. Three would be 8. Yeah, and then you go like that. So then we'll go to blue to do the This is a transformation. That x minus 2, that means it goes to the right 2. So every point goes to the right 2. So here, 1, 2. Here, 1, 2. Here, 1, 2. Here, 1, 2. And my intercept actually ends up being x-intercept. I mean, my y-intercept ends up being like, is that 1/4 maybe? Something like that. We can actually use our graphing calculator to figure this out a little bit better. So it looks like that. So it's everything transformed to the right 2. Okay. That problem actually isn't very bad. Oh, domain and range. Domain, same as always, negative infinity to positive infinity, per usual. The range is from 0 to positive infinity, per usual. The domain is going to be the same for these type of function. The range doesn't change because I didn't move it. I didn't mess with my y values at all. It's the same range of y values. That happens when I shift it up and down. That affects the range. Otherwise, no. Last one, calculator problem. A can of soda is placed inside a cooler. As the soda cools, the temperature T of x in degrees Celsius is given by the following function, where x is the number of minutes since the can was placed in the cooler. T of x is equal to -7 plus 27 e to negative 0.04x. Find the initial temperature, and then after 15 minutes. So 0 in for x, and then 0 in for x, and then 15. You could graph it and use the table, or you could plug it in. I'm gonna graph and use the table this time, just to do something different. I should do it so you can see it. Let's do that. I'm gonna find a way to do this faster. Boom. Okay. Have our old function up here. Clear. Let's see. Problem. Here we go. The problem is -7 plus 27 second e to the negative 0.04x. Graph. It doesn't show up on my graph for some reason. We could always zoom it out to see what it is, but that's not what I want. I want the table, because the table tells me at 0 that the initial degrees is 20 degrees. I like that. And then if I want to know how long after 15 minutes, I go down to 15, and it says the nearest degree. So 15 is right there, and 15 is 7.8, which is 8 degrees. So at 0 is 20. Let me go back and just write it down in case we have any people that, some people like to see stuff written. All right, so my initial temperature is 20 degrees Celsius, and my after 15 minutes rounded is 8 degrees Celsius. And that will conclude homework 12. If you have any questions or issues about it, definitely feel free to ask.